Hello everyone, today we're going to do an example question on calculating the pH of different regions of a titration of strong acid and strong base. Okay, so you're going to have a strong acid, strong base situation. Okay, so in this example question, we're going to have HCl as our hydrochloric acid as a strong acid and sodium hydroxide as our strong base. Okay, so that's what we have, and then let's start this titration. Okay, so there are 4 regions of this. So you start off with the initial pH. Okay, so initially you have to know what do you have. Okay, since we're having a strong acid and use base to titrate it, so you're gonna initially you only have your HCl, only have your acid, so you will only have your strong acid in this solution. Okay, then this is not hard at all, right? Because we know exactly how to calculate the pH of a given concentration of a strong acid. Okay, so this strong acid we have, okay, so I'm gonna use this. So pH of anything will equal to negative log of the hydronium ion. Okay, so the hydronium ion in a strong acid will be the hydronium ion concentration will just equals to the concentration of HCl of that strong acid. Okay, and then which is given in this question, so that will be 0.1. Okay, so after this calculation, the pH initially is gonna be 1. Okay, so it's gonna be 1. Okay, so let's mark it. So your starting point is right over here because you add 0 ml of the sodium hydroxide. So it's gonna be at x-axis at 0, and then the y value is gonna be 1. The y value is pH. Okay, so it's pH right here. Okay, so y-axis is the pH. Okay, so that's our starting point. It's quite easy. Okay, so now we keep on going. So now will be the region of the before equivalence point. Okay, before equivalence point. Okay, so before equivalence point, we have to recognize what is it. Okay, so basically you're gonna start to add some strong base. Okay, so before you reach equivalence point, as we said, at equivalence point, what do you have? The moles of the hydronium ion will equals to moles of hydroxide ion. So this situation will be you have, I'm gonna draw my beaker again. So you have your beaker. Okay, so you're gonna have that 0.1 molar of HCl, which is you have 25 ml inside here. Okay, so you're gonna start to add your base. Okay, Okay, sodium hydroxide. Okay, so as you're adding it little by little, so what do you think? What's this process? It's acid-base neutralization. So you're gonna neutralize this strong base you add, and then you still have HCl inside your solution. Okay, so this will be this process. I'll say you still have more of the acid right after the neutralization. Okay, so after acid base neutralization, you still majority of this solution, you still have the more of this strong acid inside. Okay, so then you recognize your pH when you calculate it's gonna be what, smaller than 7, right? Because you know you're gonna have more of this acid even after you added some that strong base, because they're gonna react. Okay, so now you recognize I probably have to have my reaction equation written out. Okay, so now let's do that. So HCl react with NaOH, gonna give us sodium chloride, which is pH neutral. That sounds good. That's not gonna affect our pH, so that's good. Okay, so anyway, so now we have this strong base. Now at this, before this is equivalence point, I'm gonna give you as example. So we're just say we added 5 ml of this sodium hydroxide. Okay, so you're adding 5 ml. So now we have a specific number, so we can do the calculation. So again, based on a reaction, we always use moles to talk about how the reaction goes with the stoichiometry. Okay, so apparently we need to calculate the moles. So added the moles of the added NaOH will be, of course, we're going to use molarity times the volume. That's give us moles, okay? So that the molarity will be 0.1 because you have the 0.1 of the sodium hydroxide times the volume you added is 5 ml, okay? And then let's see one more time. What's the capital M? Moles per liter, okay? So we have moles per liter, and that 5, yes, we need to turn it into liter. So 1,000 milliliter equals 1 liter. So basically you need to divide it by 1,000. Okay, so after you do this, this turns out to be 5.0 times 10 to the power negative 4 moles of sodium hydroxide. Okay, so that's how many moles of sodium hydroxide you added, and then you go, I also need the moles of the HCl. Yes, that's correct. Let's do that. Okay, so initially how many moles of that initial moles of HCl? We'll do the same calculation. Molarity times volume, that will be 0.1. I'm just going to use mole over liter. HCl, and we have 25 ml, so you're going to divide it by 1,000. Okay, and then you'll have 2.5 times 10 to the power negative 3 moles of HCl to start out with. Okay, so now we can do the stoichiometry. Okay, so I'm gonna set up a table. Again, this is just help you to figure out direction, how many moles reacted, how many moles left over. Again, if you know exactly this about the stoichiometry, you don't have to set up this table. Okay, we do this because it's easier. Okay, but you don't have to. Okay, so now let's do this. Okay, so we'll use the moles before, moles reacted or changed, whatever you like to call it. Okay, moles after, and the new molarity after the neutralization reaction. Okay, so we're going to have HCl, NaOH, and NaCl, and H2O. Okay, so this we don't care. Okay, so you start out with what? 2.5 times 10 to the power negative 3 moles. And then you added, at this moment, at this before equivalence point, you just added 5 times 10 to the power negative 4 moles of sodium hydroxide, and this was 0. Okay, so this is 0. Okay, and then reacted again, you have less amount of this sodium hydroxide, so this will be completely neutralized, so everything will be gone. Okay, so you're gonna subtract 5.0 times 10 to the negative 4. Since this is 1-to-1 ratio, so this much amount will be reacted, or same amount of the acid will be needed to neutralize that strong base you added. Okay, and then of course the same amount of the salt as the product will be produced. Okay, and then now you can calculate the after. You just do addition, so that will be 2.00 times 10 to the power negative 3 moles. And then this will be 0 because everything will be gone, and then you just produce some salt. Okay, and then to do the concentration, molarity concentration, what do we do? Yes, we need to use molarity will be moles over liter. Okay, so moles is easy. 2.00 times 10 to the power negative 3 moles. What's the volume? Is 25. Initially have 25 ml of the acid. You added 5 ml of the base. Okay, so now you need to turn this into liter. Okay, so you're gonna divide it by 1,000 ml, 1 liter. Okay, so that's 1,000. Okay, so you do this, turns out to be 0.0667. Okay, so that's how many was the concentration of the HCl. Okay, so I'm gonna put that into this table, 0.0667. Okay, so you can do the same for the sodium chloride, so that's gonna be 0.017 molarity. Okay, so this is the new molarities of these two. Again, this, you see, this of then whatever the concentration of sodium chloride, that actually is fine because it's not is this salt is pH neutral. Okay, so that's not going to affect our pH. So what do we really need to care about is this. This we need to use to calculate our pH. Okay, so in this case, again, it's an easy case because you will just have what? The pH of this solution at this moment. What do you really have to affect the pH in your solution? Is it strong acid? Okay, so the pH of strong acid again will be the concentration. The negative log of the hydrogen ion will be negative log of the HCl. In this case, will be negative log of this 0.0667. Okay, you do this calculation, turns out to be 1.18. Okay, so this is the pH before when you add 5 ml. Okay, so now let's do that. 5 ml approximately around here, and then the pH just around here, right? So that's 1. Not 2, but I don't have much space. It's 1.18. Okay, so that's the second point. Of course, you can keep drawing this. Okay, so you can gathering more data points. Okay, so we're not gonna do all the calculation. We're gonna do the next calculation will be at equivalence point. Let's see what happens at equivalence point. Okay, so at equivalence point. Okay, so at equivalence point, as we keep on saying, what happens over here? Okay, at equivalence point, the moles of the hydronium ion will equals to the moles of the hydroxide ion. Okay, so that's what happens at equivalence point. The acid-base argon just produce the salt and water. Okay, so let's rewrite our equation here. So that's as a reminder, so you know what's happening. Okay, so one more time, our reaction is right over here, right? Okay, so it's HCl, and then you have sodium hydroxide. You keep on adding more and more. Now you reach the equivalence point. So all of the acid is neutralized by the base. Okay, so everything turned into water and the salt, sodium chloride. Okay, so one more time at this moment. Okay, then again you have to. Sometimes we like to ask how many what's the volume you needed to reach the equivalence point. So you have to know this relationship. You have to know, okay, at equivalence point, this is what's happening, so you'll be able to calculate the volume. Okay, so as we already know, okay, so we're adding 25. Okay, so basically we already told you 25 will reach the equivalence point, so then you know also equals to the moles of the acid. How many moles of the acid we had initially? That's the 2.5 times 10 to the power negative 3 moles of the acid, so it will be the equal moles of the base. But let's do a calculation to show that. Okay, so 25 ml of that 0.1 molar of sodium hydroxide added. Okay, so we're gonna do the same calculation. The moles will equals to the 0.025 liter. I just converted already. Okay, times 0.1. That will be mole over liter. Okay, and then this equals to 2.5 times 10 to the power negative 3 moles of this NaOH. Okay, so since you have the equal moles, and they're gonna be all gone, but I'll still like to show you the table and show you from the perspective of math. Okay, so this is how it's gonna be shown. Okay, so you have all this. Okay. Okay, so you have moles before, moles reacted, moles after, and molarity. So really, once you get familiar with this, if we give you a strong acid and strong base at equivalence point, you don't need to calculate the pH, because for a strong acid strong base neutralization at equivalence point, pH equals pH equals to 7. Okay, so that's something after this you should know. Okay, but I want to show you. Okay, so over here you start off with, initially, remember the blue, I had 2.5 times 10 to the power negative 3 moles of this HCl, and now I just calculated at equivalence point, when you add 25 ml of the strong base, you're gonna have the same amount of moles, and this is 0. Okay, and then this is 1-to-1 ratio, and then that's perfect. Everything is gonna be reactive. So this will be negative 2.5 times 10 to the negative 3, negative 2.5 times 10 to the negative 3, and you're gonna produce positive 2.5 times 10 to the negative 3 moles. Okay, so this will be 0, this will be 0, and this will be 2.5 times 10 to the negative 3. Okay, and then the molarity, of course, is 0. Okay, you have none of this, and you can calculate molarity instead of 30 earlier before the equivalence point. Now you're gonna have 50 as your volume. You just do the calculations. I'm gonna squeeze in over here. Okay, so negative 3 moles over 0.025 plus 0.025 liter. That's the 25 initially you have for the acid and 25 you added for the base. Okay, after this calculation turns out to 0.050 molar. Okay, like I said, this really doesn't matter much because, one more time, that's the concentration of this salt, and this salt is what? Is pH neutral. Okay, we really don't care what's the concentration of it because it's not gonna affect the pH. Okay, so after all, you see, the substance is gonna affect to the pH, gonna matter to the pH. It's all gone. Okay, so the pH will be what? Equal to 7. It's a neutral solution. So one more time, at equivalence point for a strong acid and strong base, pH will equal to 7. Okay, so that's quite important for you to know. Okay, and then let's draw this point. Okay, so add 25, and then it's 7. Okay, so that's what we have. Okay, so and then again, you see this is gonna goes up quite quickly. Okay, and then gonna keep on going. Okay, and then let's keep on adding. Okay, after equivalence point. Okay, so we're gonna come back to that titration curve. Okay, so after equivalence point, think about it. What we're gonna have after equivalence point. All the acid is gone. Okay, all the acid is gone. What do you have? Whatever the amount you have of the base you add is only base in the solution. Okay, so I'm of course base and plus the salt, which is not gonna affect the pH. Okay, so that's why I said only base. Okay, so then just assume we're at this point we're added 30 ml of the NaOH. Okay, so you know again, so when you add 30, what happens? Yes, you do the I'm sorry, it's not S table, it's the moles table, figure out how much of the base left, and then you can calculate concentration, and then you can calculate the pH. Okay, so let's do that. Okay, so you already know what to do, right? Okay, so let's start off with the moles of this 30 ml of this base. So that's gonna be what? 0.03 liter times 0.1 moles of sodium hydroxide over 1 liter, 3.00 times 10 to the power negative 3 moles of sodium hydroxide. Okay, so that's what we added, and now let's set up the table we have. Okay, so this table now, so I assume you at this point you're probably already know exactly what to do. Okay, so the moles reacted, moles after, and molarity. Okay, and this is HCl, NaOH, NaCl, H2O. This doesn't matter. Okay, and now let's see what we start off with. Okay, so remember again, it's the same acid. Okay, so 2.5 times 10 to the power negative 3, and the base you just add is 3 times 10 to the power negative 3, and then this is 0. Okay, so we're still counting this initially. You just say add 30 at once. Okay, so it's just at 30. Okay, so that's what we have. Okay, and now again, now acid is less. Like I said, acid is all gone. It's gonna be all gone. Okay, so all reacted, and then so gonna minus 2.5 times 10 to another 3. Now you're gonna produce the same amount. Okay, and then this will be 0. This will be 5.0 times 10 to the power negative 4 moles, and this is 2.5 times 10 to the power negative 3 moles. Okay, and molarity, you already know, right? Moles over liter. Okay, so this is 0. Liter will be how much? What's the volume? I'm gonna put the volume here. What's the volume at this moment? Will be 25 ml plus the 30 you added. Okay, so that will be 55, and you can turn it into liter. Will be 0.055 liter. Okay, so make sure you do this, and then of course use this moles divided by that, and then you'll get this value will be 0.0091. This will be 0.045. Okay, and then one more time. This really doesn't matter because that's pH neutral. Again, then you go, why you do this? Why you include this? Because we need you to know this. You do produce a salt in this strong situation, doesn't matter. But when strong weak, that matters because that will affect your pH. Okay, so now let's look into the fact will affect our pH will be this. Okay, so then you have the base. Of course, you have the concentration of hydroxide ion. Okay, so that's something you also know exactly what to do, right? Okay, so since the concentration of the sodium hydroxide will equals to the concentration of hydroxide ion, so we'll say 0.0091. Okay, there are two ways now that I'm just gonna go here, calculate the hydronium ion concentration by using Kw divided by the concentration of OH. This gives me 1.10 times 10 to the power negative 12. Again, Kw equals to, let's write it, Kw equals to 1.0 times 10 to the power negative 14. So you do the division, and then you get the concentration of hydronium ion, and then the pH will be negative log of the hydronium ion, will be negative log of this 1.10 times 10 to the power negative 12, and gives us 11.96. And this should make sense to you. Remember, we said after equivalence point, you only have base, so this pH is gonna be what? It's gonna be bigger than 7, and then when you have the strong base, it's gonna quite close to a higher value. Okay, so that should make sense to you. And then again, after equivalence point, it will be for strong will be bigger than 7 because it's base, and I equivalence point is equals 7 because it's strong. All the acid bases are gone, just have that neutral salt. So that's why pH equals 7. Before equivalence point is going to be acidic because that's the strong acid you have there. So it's going to be, let's put it, it's going to be pH smaller than 7. Okay, and then when you have the initial, that'll be just how you're calculating the strong acid. Okay, and now let's see the last data point we have as 11. When you add 30, we'll add more, it's at 11 something. Okay, and then of course you can do more data points. It's gonna be roughly looking like this. Okay, so it's not the most beautiful titration curve I could draw, but that's just telling you that's a titration curve, roughly how it's gonna look like when you have a strong acid, strong base titration. Okay, thank you for listening.